Welcome back, my fellow mathematicians. I'm so glad you're here. It is time once more to do some more math. Today we're going to look at our polynomial long division. How do you divide polynomials? So if you're following along in your interactive notebook, they should be on page 34 of your notes. Well, in order to do the polynomial long division, we first have to remind ourselves, how do you just do the long division process of just simply dividing numbers? So I'm going to start with just a really simple, like we were in third grade again, dividing 277 by 12. So the first thing you do is look at the first digit of your number that you're dividing. So how many times can 12 go into 2? No, that's impossible, not going to happen. So how many times can 12 go into 27, looking at the first two digits of my dividend? How many times can 12 go into 27? Well, that would actually be 2 times, because 2 times 12 is 24. So then if I subtracted the 27 minus 24, I would have 3 left over. Then I'm bringing down the last digit of my 277, so bring down the 7. Now I have a 37 as my remainder that I have left over. So how many times can 12 go into 37? That would be 3 times. Yep, 3 times. So 3 times 12 is actually going to be 36. So then whenever I subtract the 36 from my 37, leaves me with a remainder of 1. And I'm actually, for these purposes, going to leave with the remainder of 1 because we're going to be using that later with our polynomials as part of the remainder theorem to come ahead. So leaving that remainder, if I take 277 divided by 12, that can be divided exactly 23 times with 1 left over as a remainder. So then let's transfer that exact same process to our polynomial division using, remarkably, exactly the same numbers. So what if we had 2x squared plus 7x plus 7? So exact same numbers with our 277 that we just divided by. And now we're going to divide that by x plus 2. Okay? Exactly the same process, same steps, and same procedure. So if we did 2x squared, or what would I have to multiply the first term here on my divisor? What do I have to multiply x to make it become this 2x squared? So x times what is 2x squared? Well, that would be 2x. So then I'm going to multiply 2x times all of my divisor, x plus 2. So 2x times x is 2x squared. 2x times 2 is 4x. And then, just like I did on the long division, I'm going to subtract that product. So if I take 2x squared and I subtract the 2x squared, then that's going to go away and cancel. That's what I wanted. But then keep in mind that I'm taking 7x, subtracting 4x. That leaves me with 3x. And then again, just like we did in the long division process, bring down this plus 7. So now again, I'm going to go back to my divisor. What do I have to multiply this x times what to get me the 3x for the first term here? So x times what is 3x? Well, that would just simply be 3. So then I'm going to multiply 3 times my divisor. Again, all of the x plus 2. 3 times x is 3x. 3 times 2 is 6. So then again, just like we did before in the long division process, I'm going to subtract all of that product of 3x plus 6. So if I did 3x minus 3x, then that cancels, that goes away. And if I do 7 minus 6, I still, again, have a remainder left over of 1 because I don't have any other numbers to bring down, so I cannot simplify any further. So that would end up being my, again, remainder of 1. So then my solution would actually be, or the quotient after I have divided, would look like 2x plus 3 plus my remainder written as a fraction 1 divided by the divisor x plus 2, because that's what I had left over after I divided the entire polynomial by x plus 2. So that's how you would write your solution there. So one more time, just for practice, we're going to look at another problem and divide these. So we're going to divide 6x to the fourth minus 2x cubed plus 5 divided by x squared plus 3. Now, the problem or the catch whenever you are dividing with these polynomials is that you must put your polynomials in standard form, starting with the leading coefficient or starting with the highest degree. So the biggest exponent has to be first, and it must be in descending order with no variables missing. So if you look, for example, on our polynomial that we're beginning with, we have 6x to the fourth and then an x to the third. But notice how we are missing this x squared and x terms. So then that means that we're going to have to put in a placeholder of 0x squared and a 0x before that plus 5. And also with our divisor, I'm dividing by x squared plus 3, and it jumps automatically from x squared to just numbers. So then here again, we are missing the x term, so I have to have a 0 placeholder there. Now the reason why you want to do that is because it keeps everything lined up the way that it's supposed to be, so you don't end up having, you know, an x squared that you're trying to add with just an x or anything. So it keeps everything lined up where the term should be, and it makes your life much easier and much less complicated. So then, same process that we've had before. So we are going to divide 6x to the fourth minus 2x cubed plus the 0 placeholder x squared plus 0x plus 5. So that's my entire polynomial, and I will be dividing all of that by x squared plus 0x plus 3. I'm running out of room here. All right. So then again, same process that we had before. So I'm going to focus on the 6x to the fourth. So what is it that I need to multiply x squared in order to make my x squared become 6x to the fourth? Well, I would need to multiply that by 6x squared. So then if I multiply 6x squared times all of the x squared plus 0x plus 3, then I get 6x squared times x squared is 6x to the fourth. 6x squared times 0x would then just be 0. 6x squared times 3 would be 18x squared. Okay, then, just as I did before, I'm going to be subtracting all of that. That's the tricky part. You have to remember we are subtracting with the long division. So 6x to the fourth minus 6x to the fourth, that cancels, goes away. That's what I wanted. And then a negative 2x cubed minus nothing is still going to stay as a negative 2x to the third. And then 0x squared minus 18x squared. So because I am subtracting this 18x squared, that's actually going to be a negative 18x squared. Changes the sign because I am subtracting a positive 18x squared. So then again, just as we did before with long division, I'm going to bring down the next term, which would be the 0x. So then go back to your divisor. What is it that I need to multiply my x squared to make it become a negative 2x cubed? Well, that would be a negative 2x. So then if I multiply negative 2x times all of x squared plus 0x plus 3, negative 2x times x squared would be a negative 2x cubed. That's what I wanted. Negative 2x times 0, well, that's still just 0x. And then negative 2x times 3 would be a plus 6. Oops, I'm sorry, would be a negative, scratch that, negative 6x. There we go. Okay, so then I'm going to subtract all of that product. So if I'm subtracting an already negative 2x to the third, then I'm actually going to be adding 2x cubed, which would then make that cancel with the negative 2x cubed. That's what I wanted. Negative 18x squared minus 0 is still negative 18x squared. And then 0x minus a negative actually means that I am adding that negative 6, so that makes it a positive. That's a plus 6x. Then, last but not least, bring down that plus 5. go back to your divisor. So what do I need to multiply x squared to make it become a negative 18 x squared? Well, that would just be a negative 18. So then multiply negative 18 times all of x squared plus 0x plus 3. Negative 18 times x squared would be a negative 18x squared. That's what I wanted. Negative 18 times 0 is still 0. Negative 18 times 3 would be a negative 64. So then I am going to be subtracting all of that yet again one more time. So I'm subtracting an already negative 18x squared, which actually technically means that I'm adding. So the negative 18x squared, positive 18x squared goes away. 6x plus 0 is still 6x. And then 5 minus a negative 64 actually means that I'm going to be adding that 64. That makes it a positive 69. So then all of this 6x plus 69 actually ends up being my remainder. So then my quotient for this division problem would end up being 6x squared minus 2x minus 18 plus all of 6x plus 69 divided by x squared plus 3. And I don't actually have to have the placeholder of the 0x whenever I'm plugging it back into its polynomial form. The only reason why I need those placeholders is for the division process, those purposes. So that is a quick example of the division process of long division using your polynomials. So if you have any questions, concerns, issues, please feel free to ask. I will be available before and after school for tutorials. So I hope you have a great day and we'll catch you next time.